Hi, my name is Sare Zeren Kelezoğlu. I'm a freshman student in Industrial Engineering department and I'll be presenting my Physics 101 lab experiment today. My experiment is about finding the terminal velocity and finding the drag force and drag coefficient of an object if thrown for free fall in different density fluids. My objective is to compare these values and find the relationship between the density of the fluid and the drag force and drag coefficient and the terminal velocity of the object. First, I'll throw a metal sphere inside the bore glass tube and film the process, and then I'll use those videos to find the terminal velocity of the object. And using the terminal velocity, I'll be calculating the drag force and drag coefficient, since in the terminal velocity equation, all of the variables except the drag coefficient will be known if I calculate the terminal velocity by using the videos. And for this experiment, I need a bore glass tube, a scientific calculator, your phone or a camera to film the process of the free fall, different density fluids, a metal sphere, and a chronometer. The following videos will be me performing the experiment. The fluid in the first video is honey, in the second video it's a detergent, and in the third video it's glycerol. Using the shown videos, I calculated the terminal velocity of the objects. And for this soap, it was 1.49 meter per second. For glycerol, it was 0.96 meter per second. For honey, it was 0.40 meter per second. And we can say that as the density of the liquid increases, the terminal velocity of the object decreases. And about the drag force exerted on the metal sphere falling when it reached terminal velocity was equal in all scenarios, since drag force is supposed to be equal to mg when it reaches terminal velocity, which is not dependent to the density of the liquid. So it was expected for it to be equal, and it was 0.32 newtons for all of the scenarios. The drag coefficient was different with different density liquids, but it doesn't have a decreasing or increasing way dependent of the density of the liquid. For this soap, it was 0.92, for glycerol it was 1.76, and for honey it was 0.074. So yeah, as I said, I couldn't find a relation between the density of the liquids and the increasing and decreasing of the drag coefficient, because I believe, like, in the theoretical way, it can be calculated with other equations too. It usually is dependent on viscosity, so I believe these numbers are indicating the viscosity of the liquids. I can't do any percentage error calculations in my experiment, but I can maybe like observe some possible errors. I can think of how errors occurred, but I can't do percentage error calculation since in my equation there were two unknowns and I tried to calculate them by myself. And it was not like how gravity is known or how there is no way of it being like a supposed to be way. There is no theoretical background. So thank you for listening. I hope you liked my video.